Good evening. Thank you guys so much for having me. My name is Stephen Fluin, and I'm a developer advocate on the Angular team at Google. So what is a developer advocate? My role at Google really has two parts. The first part is to help developers and organizations be successful with Angular. And the second part is to understand what it's like building software in the real world so we can reflect that onto the team to make sure that we're helping to make the right sorts of choices as we go along. So before I start here, how many people are familiar with Angular? Okay.
What do you mean by familiar?
How many people here have written Angular or AngularJS code in the past? Okay, great. If I go too fast or I talk about something that you've never heard of before, feel free to stop me and I can kind of break things down and explain as we're going here. So I'm really here today to talk about the combination of Firebase and Angular, which are both Google products that we feel like make building applications a little bit faster and a little bit easier. A lot of people tend to not think about data when they're choosing frameworks and when they're starting off a new project, but data ends up being essential to a lot of the things that we do, because without data you're really just building a calculator, right? There's not very far you can get in software engineering without pulling in some sort of data from an API or creating data yourself and pushing it to somewhere. So I don't have the slides posted right now. If you follow me on Twitter or just pull me up there, I will post all the slides after so that you can get access to all the content here. So how are we going to do this today? So I'm going to give a quick introduction to Firebase and all the different pieces of Firebase, because it keeps getting more and more complex. Then I'll go into a tool called Angular Fire, which we're going to use to kind of combine these two technologies together. Then I'll do a live coding demo, see how much time we have here, see how quickly I can build something out for us. And then lastly, I'll end with a couple slides about how this really gives you superpowers in terms of the ways that you can build applications that connect to your developers. And I want to start with a funny story that actually happened. So the genesis of AngularJS. So think 2009. We were all writing jQuery at the time. We were building websites. We were manually poking the DOM and moving things around ourselves. And the gentleman by the name of Miško Hevry said, hey, this is really hard to write, right? We've spent 6 months building out this tool. I want to build an application in a better way. I want to have more centralized concepts. I want to have dependency injection. I want to have a services layer. I want to have more control of how I build my application out. And so he began writing Angular. And his original vision was it was going to be an end-to-end framework. And so it was going to combine all the way from the front end all the way back to the server. And so trying to take care of all of these things on both sides of the world. But as we kind of know, he gave up very early on in handling the server side of things because that's a very difficult problem to solve. But if we flash forward now to 2017 and even back to, I think, 2015, we had this introduction of a product called Firebase from Google, and it was actually formed by a bunch of former Googlers who then got acquired back into Google. But it really solves a lot of the problems that we have when we're building out complex data sets that we want to host on a server somewhere and then access from a front-end application, whether that's mobile or web. So let's dive into a little bit about Firebase. So on the website, it says Firebase helps you build better mobile apps and grow your business, which is a really nice kind of marketing term. But what does that mean for us? A lot of us being web developers and focused on delivering applications on the web, right? We develop with the web. What do we care about mobile? One of the very interesting statistics that I've seen, at least in a couple different countries, is that most consumption of web applications now is mobile. So if you're in the US, about 70% of web applications are consumed via mobile. If you're in a country like China, it's about 90%. And so thinking mobile first and thinking about delivering these experiences down to your users with platforms like Angular is a very important thing, because mobile is one of the key places that users are experiencing your facts, your data, all the features that you're offering them. But Firebase has a lot of different features. Only a couple of them are purely mobile focused on more traditional Android and iOS. A lot of their features are cross-platform, and you can build with either the web or these kind of native mobile platforms. And so I will focus on these 5 to kind of start in terms of the background. So we have database. So Firebase is what's called a real-time database. Focus on authentication. So how do we identify our users? How do we connect to them? How do we have usernames and passwords, things like that? We'll go into hosting, so how do we host this? How do we host all of our application code? Storage, which is going to be very simple, straightforward. And then something new and kind of interesting called cloud functions. So let's quickly go through these one by one. So the first thing they have in Firebase is a real-time data store. And so what do I mean by that? This is a real-time NoSQL database. So how many people here have used a SQL-based database, like MS SQL, MySQL? Okay, most of us. How many people have used a NoSQL database? Okay, a bit fewer of us. So If we think of traditional SQL databases having tables and key index and private keys and things like that, a NoSQL database is effectively just a document store. So everything, if you think about like a JSON object, is just a map, a nested map of keys, objects, and lists of items. Built into the real-time database, they have a WebSocket-based communication protocol. So we're very used to building kind of RESTful applications where we're going to make a call to the database every time we want to figure out what's going on. Instead, what they've done is they bootstrap that process. So initially, it's going to make a RESTful call to a backend, but then after that, it's going to be opening a socket connection so that the server can push any data down to your application while you have it loaded. So the server can say, hey, this piece of data changed. The user cared about this piece of data. Let's give it to them immediately without the web application have to continually request or refresh that, making it nicer on the network connection, making it nicer on the server in a lot of different ways. They also offer a RESTful API, so if you do want to build more of a traditional application on Firebase, you can do that. And essentially everything that you're going to be doing with Firebase is you're going to be binding into specific objects or lists within Firebase, and then those will come out as an event. And so if we take a look at a event example, so this is basically a JSON object that I've stored in Firebase for a conference. So this is a conference website, basically. So we have a private key here at the top, and what this is a list of speakers that might be speaking at that event. So we see Brett, he works at Google, he's got a name, and then we have this kind of, it looks a little bit like an array, but it still is a map. And that's actually a really important point, because when we think about scaling data out, arrays don't scale well. So let's say instead of 5 items or 10 items or 50 items in our database, we have 1 million items or 2 million items, and those items are sharded across multiple servers across the globe. If a user wants to see a specific item, or let's say they want to make an update to that specific item, if we used arrays and array keys, item number 7,800,064 might not be that same item in the array after that user is interacting with it, right? Things are going to change so fast that you don't want to be keying on those indices. And so Firebase is going to be generating these magic keys for you that ensure that as your database scales, you're still able to access and update and know what data you're talking about. And so the server and the client aren't going to get out of sync. They have a really nice backend that they've built out. So this is all built in JavaScript. And what you can do is you can dynamically and in real time descend into your data using these kind of pluses and minuses. You can make updates, you can add data, and we'll take a look at that using the Firebase console in a little bit. So we talked about how maybe we have a list of speakers. In Firebase parlance, that's called a ref. So you're going to refer to a subset of my data that exists on the server. And then I'm going to get a sequence of events, such as child added, or child changed, or child removed. And what this does is this allows me to say, hey, every time one of these things happens, what do I want to do with my user experience? So if I was still writing all of my applications in jQuery, I could use Firebase, and then they call a method in my application, such as child added, whenever we add something to the list. So maybe my list went from 100 items to 101, and then I can say, what do I want to do with that item? Do I want to append it into the DOM? Do I want to render something, show a really cool animation? And then you can do that with all of these kind of different events. So this is for lists, and we have a very similar list of things that happen for objects. They also have a very important server-side model for security validation. So as some of us may know, building applications, you can never trust the client. Whether it's an iOS or an Android app, whether it's a web application, you can never assume that the user is going to send you data following your rules, right? So a lot of people implement kind of client-side validation where you say, hey, you have to be an admin in order to post this data, you have to have access to this data set in order to be able to change it. Angular, all of those rules that you apply, users can bypass them, right? They can open the console and say, no, let's change this variable from a 2 to a 3, or instead of updating item 7Q, I want to update item 8A, right? And so Firebase has a JSON schema here where it allows you to say, here's the different data sets that exist in my data store and the permissions that I want to apply. So I'm going to walk you through a couple examples here. So at the top, we have a relatively simple one here. So I've got a subset of my tree of my NoSQL data store called users. And what I'm doing here is I'm saying I can only access items in the tree with a user ID where that user ID matches the one of the user that's authenticated, right? So this gives me write access to all of my data and no one else write access to all my data. So that's a relatively straightforward one, but we can actually do a lot more complex things. So I can actually do a lookup from within Firebase to a different part of the tree. And so this is, for example, if you have a set of volunteers at an event, and you want to manage who can modify the data for those volunteers, I can say, let me validate that the user ID that is trying to make this change exists in a different part in our database, right? So we maybe have this admin section. I can say, make sure that user exists in this other part of the tree before you allow them to make any changes. And then it really is just kind of JavaScript under the hood, so you can do all sorts of ands and ors to do combinations of this data set and this logic. So this is a really complex example that says, okay, underneath the sessions, right? So maybe there's 30 sessions at a conference, and I want to allow volunteers to only edit the notes of any session. Then we can actually check what parameter modifying, whether they are a volunteer or whether they're an admin. We can go as deep or as complex as we want to, but it's applying server-level validation, so no matter what a user does in the console or as an application developer, they can't change those things maliciously. So it's a very strong, very kind of secure security model that you can apply to applications very quickly. So the next feature, this was a little bit dependent on when we started talking about the security rules, is authentication. So Firebase is really trying to abstract the kind of tough process that a lot of developers have gone through in terms of integrating with all of the different authentication providers out there, right? So you can do Facebook sign-in, Google sign-in, Twitter sign-in. What they're trying to do is they're trying to give you a single API that gives you access to all of these things so you can expose them in your application more easily. So they actually have a list here. So you've got all the normal ones, Google, Facebook, Twitter, GitHub, but they also have a couple of more interesting ones. So you can actually set up your own username and password authentication, for example, if you wanted to, and then store that in their database and use their methods. So the user would just have a one login button, and then if you wanted to change the backend to a different authentication provider, that's really, really simple. They also have things like anonymous. Maybe you want to allow users to have a session that exists for the duration of their engagement and store data about that session, but then you want anyone to be able to kind of blow that away. You don't want to require any sort of login with any other third party. So that's one of the options. It is relatively simple to turn these on. You just click on them and you say, yes, turn it on. The next piece that they've got is hosting. So typically when we build a JavaScript-based application, we have to put that somewhere. This is relatively easy with Firebase, and we'll actually do this live. So you do Firebase init to create a project and attach it to Firebase. And then I'm going to run Firebase Deploy, which is going to take all of my static assets and just move them to the server. It'll copy them to the server, and then they have built-in processes for doing revision control. I can roll back if I didn't like a deployment and things like that. So if you do Firebase Deploy, it's going to look like this. You're going to get nice little emojis, deploying database, deploying hosting, deploy complete, and then it's going to give you a URL. A couple very nice things about Firebase Hosting is that they do HTTPS and SSL out of the box, so that your user's connection to the server is secure by default. And then for free, actually, you can connect one of the Firebase apps to your own domain name. So you just go and you say, here's my domain name, you do the validation. And so it's really, really easy if you just go and buy a domain name to say, hey, let me take my Angular app and I want it to be myname.com. That's a very easy process to do. Another thing that they do as part of Firebase Hosting is they manage all of the caching for you. And so you've pushed these files onto a kind of theoretical server somewhere. But what will happen is, as more people access your application and as more people access your files, they will actually manage caching for you. Right? So if you have a very, very popular application used by people all over the globe, they will automatically keep copies of your app or cache copies of your application in all the places that they need to. And then when you do the deployment, they automatically do the cache invalidation so that apps that are hosted on Firebase scale really, really well. Next product is storage. So if anyone has used Amazon's S3, I would probably get in trouble for saying this, but I think they're somewhat similar in terms of the ability for me to push blobs, kind of binary blobs, so pictures, files, things like that, up to the server, and then I can manage the way that they're hosted. I can say, here are the headers that I want you to host, here's the cache update policy, all those sorts of things. So when my user says, I want to upload my picture and put it as the icon on my user, you can host all those files relatively straightforward. So it stores files, pretty simple. And the last one here is Cloud Functions. So the way they describe Cloud Functions is a little bit complex. So they say, run managed backend code for your mobile app that extends and connects Firebase features. But what I like to think about this is really the next generation of what a lot of people are calling serverless development, where I build an Angular application, I build a web application that runs entirely in the client, but then every now and then I want to do something on the server, right? Like I want to validate that the user has submitted the correct data. Or I want to say, hey, every time a user submits a piece of data, let's increment a counter by 1 or record something in an audit log. And Cloud Functions is really the ability to now deploy code that runs on the server that interacts with and engages your application. So you historically would have to, as soon as you get to those edge cases of Firebase, where now I want to do some additional stuff where I can't fully trust the client, I have to spin up a server myself. But now you can really just deploy simple kind of JavaScript functions into the cloud that then get executed whenever needed. So they apply any sort of server-side validation or logic. This is a very common use case. And everything, if you've worked in Node before, which is the kind of server-side JavaScript ecosystem, it's going to be very, very familiar to you. You can even run Express in there in the use case that I'll talk about a little bit later. So the next piece of technology that I want to talk about is Angular Fire. So Firebase is a service from Google that does all these sorts of things, the hosting, the database, all those kind of bits and pieces that you need to build out applications without having to run your own server. Angular Fire is the piece of technology that kind of connects these two things. So it exposes all of the Firebase capabilities with an API that looks very familiar to Angular developers. So you don't actually have to use Angular Fire. You get JavaScript methods as part of the web SDK from Firebase. The onChild added, the onChild removed. You get all those things just from Firebase. But we like to, as part of the Angular team, give you a little bit more help, because we can take all of that data and we can marshal it into the view of your application a little bit more easily. So Angular Fire is really only focused on the first two products that we talked about today. So we're going to talk about database integration, so they help you get the data in and out, and then they help you with authenticating your users into your application. They have future plans to do things like hosting and storage management and things like that, but those aren't here today. So setup for Angular Fire is relatively simple. So whenever I talk about code samples, I'm going to assume that you've used the Angular CLI. So we have a very simple tool called the CLI, where you just say ng new, and that creates a new project with working build system, working development environment, all of the kind of stock files you need to make everything work. And then as soon as you've done that, you can run yarn add Angular Fire 2 or npm install Angular Fire 2, and that will pull it down and install all of the different pieces that you need in order to write your code. Then we're going to add some Angular modules or ng modules. So we're going to pull in the Angular Fire module, the Angular Fire database module, and the Angular Fire auth module. Originally, with this tool, you had all of those tools in one. But one of the things that the Angular team is really focused on right now is helping developers ship smaller amounts of code down to the browser so that you get faster bootstrapping, better experiences for your users. And so we've started to see all these things kind of split up so that you can pull in the minimal set that you need in order to build your application. Because in general, Firebase is actually quite large. So for example, pulling in the database module, I think, is several hundred KB. Because it has all of that offline persistence, it has all of the WebSocket connection code. So if you don't need the database and you just want authentication, you can do that. And another side effect is that you can actually split these things into different parts of your application. So let's imagine that you have a home page of your application where you don't need access to authentication, or you don't need access to the database. You can say, hey, let's build an application so that we take those things out of the critical path, and we'll just load them later when we need them. So Angular Fire takes all those methods that we talked about a little bit earlier, and then exposes things as an observable, which I'll get into and give a bunch of examples on. And then it also wraps that observable in a few different methods that should look very familiar. So if you get a list from the database, so we're going to use the list command from that, you can push a new item into the list, you can update an existing item, or you can remove an existing item. And then you can also bind into an object, so that's any kind of arbitrary subset of that tree. You can set that, which overwrites everything. So if I take a big complex object and I set that to a very simple one, you'll lose all that other information. But you can also update. So let me just take all the differences and say only the things that are specified should be updated in the data. And then you can obviously remove any subset of the tree. So the other piece is authentication. So if you're using Angular Fire auth, you can write a very simple login method. So if you imagine a login button at the bottom that says login here or sign in with Google, when you click on that, you can invoke a login method. And then I'm just going to call out to the service and say sign in with pop-up. So this is how I say, from a UX perspective, how do I want to present this to the user? So typically, if you're doing sign in with pop-up, what you'll get out is kind of on top of the user screen, they'll say, hey, please sign in with Google, and then they'll get the standard secure Google sign-in. And then we're saying, use this auth provider, so use the Google auth. If I wanted to give them a Twitter button and a Google button, then I could have two buttons, then use the different methods. Signing out is relatively straightforward as well. You just call the sign out method, and the user's credentials will all be destroyed safely, and the application will just react to all those changes. The other piece of this that is really helpful is that you get out the OffState. So this is an observable. So for those of you who don't know, an observable is something that we use a lot in Angular, where instead of like a promise where you're going to get exactly one set of data at the conclusion of an asynchronous event, you're going to get a stream of data. And so basically what happens is OffState is going to automatically update every time the user's state changes. So that could be if they sign in, that could be if they sign out. And what will happen is you can use this data and you can design your UI via templates to automatically react to changes in this. So you say, hey, if my auth state is valid, then show my edit button. If it's not valid, don't show the edit button. And then no matter what happens in your application or the user's authentication state, it'll automatically be reflected within your UX. All right, so doing a demo, I'm dependent on the internet here because we're connecting to a backend server. What could go wrong, but we're going to give this a try here. And so the specific project I'm going to do is I'm going to create a brand new Firebase application. I'm going to connect to Angular Fire. Then we're going to list messages. So we're creating kind of a women who code chat room. We'll connect to Firebase, we'll download the list of messages, and then we'll allow the user to post a new message to the screen. So as I said before, this is going to be started completely from scratch. And I've got about 20 minutes, so that we should go fast here. If anyone has not used Angular or the Angular CLI before, this is the default setup that you get from an Angular application. Hopefully everyone can see. So you're going to get a lot of files that you don't care about as a new developer. So you get tests, you get configuration files, you get build systems, you get readmes. Those are all things that you should probably worry about someday. But to start, I always just dive directly into source/app. And so this is a stock Angular application where we have a module, and that module sets up the context. So everything that, all the dependencies that I have, all the pieces that I want to be available within my application. And then we have what are called components. And so the component is an individual kind of block of UX that is going to be on the screen. And so we have one component here that says, I'm setting a property called title to app. And then we're rendering that out with a bunch of HTML. And so if we look at our browser, we see welcome to app. So this was just stock. They gave this to us. If I just delete everything above and below here, we should see a much simpler application. Welcome to app. So every time I hit save, the CLI is going to automatically refresh for me so that we'll have all this kind of live updating as I'm coding. And so the first thing I'm going to do is I'm going to pull in a few modules that we're going to need. So this is a working Angular application. You can actually see it here in the terminal. I've run the command called ngserve, and every time I hit file save, it's automatically doing all the transpilation necessary, all the bundling, all the minification, in order to ship that to the browser in a way that the browser understands it. So in my module here, I'm going to go ahead and I'm going to pull in the 3 Firebase modules. So I'm going to say import Angular Fire module from Angular Fire 2. And then I'm going to import Angular Fire database module from Angular Fire 2/database. There will be typos. If you see one and you call it out, I'll give you a sticker or a shout out on Twitter or something like that. Especially if you help me. All right, and then we're going to import the 3rd module here, so Angular Fire auth module.
Do you need at?
No, so Angular Fire 2 is sort of in a separate NPM scope, just called Angular Fire 2. Most of because it didn't start as an actual Angular project, it started from the Firebase team, but we worked together on it. All right, so we've got those 3, and I'm also going to pull in one more because we want to do a little bit of forms, because we're going to want to have the user do input at the bottom. So I'm going to import the forms module from @angular/forms. All right, so now we've done a ES2015 import. So now all of these symbols are available, and then I want to add them to my Angular application. So I'm going to define them down here. So I'm going to say Angular Fire module dot initialize app. And so what this is going to do is it's going to call a method that connects us to the database in the appropriate way. And then I'm just going to add the other 3. So we're going to say Angular Fire auth module, Angular Fire database module, and forms module. All right, so in order for us to actually initialize our connection to the database, I'm going to have to open Firebase. So let's go to Firebase console. So I've already created a project. I did this afternoon because I didn't want to risk it with you guys, and it said I was almost out of accounts. Oh, this is not going to work. All right, let's switch over here. So I'm just going to hit go to console in the upper right-hand corner. If you have a Google account, I think it's very, very easy to get a Firebase account. And then I'm going to click on Women Who Code London Chat Demo. So I'm going to say add Firebase to my web app, and they're going to give me all the configuration I need. So API keys, message IDs, bucket identifiers, things like that. And I'm just going to copy and paste that into my application here. That worked. I have an extension that does additional, like, hey, how should I be writing my code, so it doesn't actually like the double quotes. So we'll just change those all to single quotes. All right, so we've now pulled in all these things, but we're not actually using them yet. So our Angular application now knows about how to interact with Firebase, it knows how to build forms. So let's jump over to our HTML and actually do something with this. So what I'm going to do is I'm going to say, I'm just going to create a new H1, call this then I'm going to create a new div. We could theoretically style this later, so you could say like messages. And then I'm going to create a div for every message that comes back from Firebase. So I can do this all declaratively. I can say ng4, let message of messages. And then I'm going to want to get all that data asynchronously, so I'm going to use what's called the async pipe. And so I write this very declaratively, and what's going to happen is Angular is going to figure out how many messages there are, when they're added, when they're removed, and then it's going to show exactly one of these divs for each of those. And so we'll just put some simple code in here. So we'll say message.body by message.author maybe. So I'm just making out this schema on the fly here. We could put anything we wanted in here. And it's giving me an error that messages doesn't exist. So let's go ahead and define messages. So pulling in messages down from Firebase is actually relatively simple. We just need to import Angular Fire database from Angular Fire 2/database. So this gives us the symbol that identifies the service, and then we're going to use Angular's what's called dependency injection to get a handle on Angular Fire database. So I'm going to just create a local variable called db, and I'm going to say Angular Fire database. And so in our constructor, we now have access to the database service, and then I'm going to create a local variable called messages, and I'm going to say this.messages equals db.list. So if you remember that list method. And then I'm going to list everything in /messages. All right, and let's see if that worked. If that worked, this is going to be very boring. Because we have no messages in our app. That's a little bit too big. But here, our app works. We have no messages. So let's go ahead and do this side by side and actually create some messages. So what I'm going to do is in the Firebase interface here, if I can make it bigger and side by side, is I'm going to go into the database tab. So that's where I spend most of my time. I've already set up rules. So by default, when you create a new Firebase database, you can only access it if you are authenticated. So this is what ended up happening was people were creating databases and not putting any security rules in, which then meant anyone could modify anyone's data. And so they kind of flipped it and they said, let's make it secure by default. So I've just gone and turned this off just for the demo here. We have a null object. So our NoSQL store is completely empty right now. So let's go ahead and create a messages list. And then I'm going to say A1. And then I'm going to create an item here, and what do I call it? Body. Hello, world. And then we'll call the author Steven. Right. So the moment I added that into my database, it was the equivalent of another user adding it to the system, and it showed up instantly. If I deleted this, it would disappear instantly. So now we're pulling down data from the database. So no matter how many people are using this, no matter how scaled my app gets, the data is all flowing instantaneously, which is kind of magical, right? So in very, very short line of code, we now have an application that's built and rendering based on the data that we put into our app. So now let's make it a little bit two-directional. So let's actually add the ability to create content. So in my HTML here, at the bottom, I'm going to create another div. So let's create a form instead. Let's say ng no form. And I'm going to create a submit method on here that says send. And we'll send whatever our new message is. And then I'm going to use Angular's binding syntax to create two form elements. So I'm going to use the banana in a box. So we use the term banana in a box because it's brackets, square brackets for binding down, and then parentheses for binding up, so binding to an event. And then I'm going to say ng model. And I'm going to say new message.body. Give it a placeholder just so it looks nice. Message. And then we're going to say create another one for author. Alright, so now we've just created our 2 form elements, and we probably need a submit button. We don't do anything with this. Alright, but we're getting a few errors because new message doesn't exist. So let's go ahead and initialize that as an empty object here. So this is going to have an empty body and an author of empty. Alright, so if we update this and touch this form, that error goes away, but we still need to implement the send method. The send method is going to be very, very simple. We're going to say send, we're going to take in a message. We're going to say this.messages, which is our Firebase list. So we said, if you remember, we called db.list to get a list of messages, and I can say .push. Or I should be able to say .push. All right, and then I'm just going to pass it the message. And so because we bound into messages and we told it it was a list, it's going to automatically create the identifier for us and attach it at the right place in the database. And I want to do one more thing here, event.prevent default, because I just don't want my form element to refresh the page when we submit it. So that should theoretically be it. So let's actually take a look at our application and give it a try. Now that we've broken something, I can tell, oh there it is, hello world by Stephen Bloom. Okay, we didn't break it. So I'm going to say, hi there. And as we add messages, we not only see them on our screen, but we see them in the database interface here. We can make this a tiny bit nicer. Maybe we clear out the body every time the user writes something. So just new message, body, empty string. So whenever I send a message, we can automatically clear it. So I'm going to say, this worked the first time from the demo gods. And what we see here, it's coming in a little bit slowly. I think that's just because of the internet connection. There we go. So all these things, once it has a socket connection, it's going to come through much faster. And it all renders perfectly. So in about 10 minutes, I think, or 15 minutes, we've now built a full chat application where multiple users can send. You could have a user over here and a user on the right. So now we've created a live chat application just by using the Angular Fire library, so doing this very simple binding. And then they could declare a template syntax that allows us to render whatever we want to the screen. Any questions on this before I proceed? Yeah.
If you wanted to do it in a TDD way, what testing frameworks do you use?
So the question is, if you want to do a test-driven development with Angular and Firebase, what would you do? So my question would be, what are you testing? So if you're testing to make sure that Firebase works, then do an end-to-end test that pushes and pulls data from Firebase. But you probably don't need to do that because that's the whole point of the service is kind of very huge uptime, very high reliability. If you wanted to test my form, then maybe I would want to pull the form itself out into a separate component and say, here's a create method, here's a read list element, or read list. So it's all about what you're trying to test. So in Angular, just in terms of background, we highly believe in tests. So it comes from Google, and everything we do at Google has to be tested, otherwise it doesn't get into the code base. So what we do is every time you create something by default, we're going to give you a spec file. And so this spec file is using Karma under the hood. So this is a unit test and what it looks like for a component. So it configures a testing module, ensures that the component can be created, it ensures that the component should have that title app. So obviously we've invalidated this test in our work here. But not only do we give you unit tests, we also give you end-to-end tests, which might be a little bit more interesting. So if you look in this E2E folder, we use a tool that we developed called Protractor, which spins up, it's a little bit small. So it's a layer on top of WebDriver. And so all it basically does is you say, I want to run my application in an end-to-end environment. And so it's going to spin up a browser instance. It's going to connect to it using the debugging protocol. It will click on the buttons that you tell it to click on, and it will look for the things that you say should exist on the screen to verify that at each stage of the application, it's responding in the expected way to your inputs. Is that an okay answer? Any other questions on the demo? I know I went really fast.
This one is so fast on the browser is because it's connected to Firebase via the web socket.
Correct.
So what happens if you have a browser that doesn't support WebSocket?
So if you have a browser that doesn't support WebSockets, I believe you can configure it to use long polling or just repeated polling.
Or you mean like XML HTTP request, AJAX?
Yes. So that's what it does under the hood if you don't have WebSockets. one of the very cool techniques that I'm a big fan of is building applications for offline. And so how many people here have heard of progressive web applications? Okay, a few of you. So progressive web applications are basically a new set of APIs that exist in the browsers today that allow us to build radically more engaging apps via the web. And so the way they do this is they expose a couple APIs. And the most important API there is called service workers. And so what service workers allow you to do is it allows you to install something on the user's browser that's very lightweight, very controlled in terms of how much resources it can use, how big it is, but it is capable of proxying every single request that the user makes to your application. And so if I had installed a service worker, and we can actually do this, it's relatively straightforward in Angular. You just say to the CLI, I would like a service worker, true. Sounds pretty easy. And so now what's going to happen is Angular is going to automatically add a service worker to my application. So when I first load this website, it's going to install that service worker to my computer, and then that service worker is going to go and fetch all of the files that are necessary to run my application and cache them offline. And so the magic here is a couple things. So one, if you're on a Android phone and the browser decides that the user is highly engaged in your app, so they visited it a few times over a few days maybe, it's going to pop up a little prompt and saying, hey, do you want to install this to your home screen? Which can be a really good way of building more engaging experiences because now you're getting that home screen real estate that was traditionally reserved for apps in the App Store. The second thing is when they click on that, they can actually get an app-like experience. So a splash screen can pop up, and then they don't have a URL bar, they don't have a browser experience, but it's still your app. You still built it in the exact same way you did before, and then using some very simple techniques such as the service workers caching, you can take all of the content of your app and keep it offline. So one of the techniques that you can say is, hey, anything that comes from /cdn/ or whatever your content delivery network is, we can take all of those files and as soon as the user encounters them, keep a copy of them. So that when the user visits your application again, you don't need to make a network hit, you don't need to do anything. Even if the user has lost their internet connection entirely, they're on a train, they're on the subway, they can use your app. And this is a set of kind of superpowers that you didn't have before. Any other questions on the demo? Right. Yeah, sure.
So because this Firebase, you said you can use without Angular framework, secure JavaScript.
Yes.
So that means I can use any of the JavaScript framework like mobile, like Ionic, Electron, frameworks.
Yeah, so Ionic is built on Angular today. So if you're using the latest, so Ionic, for those of you who don't know, is a framework that is trying to make it easy to ship applications on mobile. So when I say mobile, I mean installed mobile. So in the App Store, in the Google Play Store. And the way they do that is they use Cordova under the hood. And then they also have a large suite or a large library of components that, depending on the platform you're targeting, they look a little bit more Android or they look a little bit more iOS. And so Ionic, they've done a huge amount of work. They've actually been out at our offices. We've been out at theirs. So we collaborate quite heavily because they, under the hood today, are using Angular. Electron, for those who don't know, is a desktop framework. And so you can actually ship Angular apps and other JavaScript framework-based apps down to the user's desktop. So imagine on Windows a .exe file, on Mac a .dmg, where you actually install an app, but it's still using web technologies under the hood. So if you look at this IDE that I'm using, so I'm using something called VS Code or Visual Studio Code, this is actually an Electron app. So this is a website that looks and feels and acts like a desktop app. Also, you can see this with the Slack application. That's an Electron app. So I'll jump back to my slides just for a tiny bit, and then I'll answer any more questions that come up. So I think we succeeded. We created a new Angular application that connected to Firebase. We were able to list messages and post messages. Hooray! So what else could we be doing with these sorts of things? So one of the kind of radical new things that was released over the last few months is what's called Cloud Functions on Firebase Hosting. And so we had this ability to write JavaScript functions that run on the server before. And what they've done is they've combined that with the hosting providing that they do. And so what I can do now is I can build an entire server myself on Firebase. And so the hosting, so yourdomain.com, or .co.uk probably, sorry. When a user visits that request can be passed into Cloud Functions, and then you can run JavaScript in order to return something to the user. And so instead of just serving static files, which Firebase Hosting traditionally did, now I can return dynamic files. And so I'm actually running code in order to respond to requests. And this sounds a little bit more like traditional server-side development. So why would you want to do this? We have a really cool project on the Angular team called Angular Universal, which is the idea that we can run Angular apps on the server, figure out the fully rendered HTML, what it would look like, send that down to the user, and then bootstrap the client-side Angular on top of that. And the reason we might want to, this is also called server-side rendering. And so the reason I would want to do that is because while JavaScript runs really well in Google search, it runs really well on user devices, not all web browsing is being done by humans. A lot of web browsing is actually done by computers. So if, for example, I want to share a link to my web app out to Facebook, Facebook is going to look at my website and say, hey, what's there? And they're going to try and generate a thumbnail. And so having the ability to run code on the server, ship down a fully rendered version that a bot can parse and create a thumbnail or a screenshot of, that can be very powerful. Because we have Angular Universal, I can write my application using all this kind of cool client-side code, the binding, the HTTP calls, all that stuff, render it server-side, bootstrap client-side, so that both computers that are looking at my site benefit, as well as users. And then you can kind of combine that with the power of Firebase's kind of global CDN and their global caching, so that we automatically get all the performance benefits of their giant network. So I can use Cloud Functions to render my Angular application, so I'm running it on the server, sending it down to the user, and then we run Angular on top of that, so you get the best of both worlds. The one other thing that I really want to talk about, if anyone is working in more of an enterprise environment where I'm building kind of cool CRUD, create, read, update, delete style applications all the time, role-based access control, or RBAC, is something that's very easy to do with this sort of Firebase authentication and the way that we have our declarative templates. And so what I can do is I can take this auth state that I get from Firebase Authentication, and I can say, hey, let's combine this auth state with a database lookup. And then let's combine that database lookup with some logic to say, is this user a volunteer? Are they an admin? Are they a privileged user? Are they a visitor? And then what you can do is you can map those things out into observables. And the reason you do that is because then I can, in my template, say ngIf is admin. And then the moment the user logs out, anywhere in the application, that observable chain will execute, and then my UI will react, so that the user can only see, for example, an edit button on the screen when they are a admin. So this is a very powerful thing. I've given some demos on this. I'm happy to talk more about this, because it's a very cool way of building applications that are consistent no matter what state the user's in. Thank you all so much for having me.